Today we will learn about calculating the charge on an object or the charge of particles. Let's talk about the charge of electrons first. The charge of electrons is equal to the number of electrons multiplied by the charge of one electron, which means that if we have one electron, it means that its charge is negative 1.6 times 10 to the power of negative 19 coulombs. If we had two electrons, then their charge will be 2 to negative 1.6 times 10 to the power of negative 19 coulombs, and so on. So the charge of electrons is equal to the number of electrons multiplied by the charge of one electron. Same thing applies for protons. If we have one proton, its charge is positive 1.6 times 10 to the power of negative 19 coulombs. Let's say we have 15 protons. Their charge will be 15 multiplied by 1.6 times 10 to the power of negative 19 coulombs. So the charge of a group of protons is equal to the number of protons in that group multiplied by the charge of each proton. Now, how to calculate the charge of an object? We know that the object is made up of matter, which is made up of molecules. In molecules we have atoms, and in the atoms we have the nucleus containing the protons and the neutrons, and we have the electron orbits carrying the electrons. So to calculate the charge of an object, we will say the charge of an object is the sum of charges of all electrons and the protons it contains. We neglected neutrons because neutrons carry no charge. They are neutral particles. So the charge of an object, Q, is equal to the charge of electrons, Q electrons, plus the charge of protons, which is Q protons, plus the charge of neutrons, which is always 0 because the neutrons are neutral. So we get this formula, Q equals QE plus QP, and when we replace QE is the charge of electrons, we replace it by number of electrons multiplied by the charge of each electron, as we saw in the previous example, plus QP, which is the charge of protons. It is equal to the number of protons plus multiplied by the charge of each proton. Let's take an example about this and see how to solve it. Calculate the charge of an object containing 5,000 electrons and 4,800 protons. So Q is equal to QE plus QP. Then Q, the charge on the object, is equal to the number of electrons multiplied by the charge of one electron plus the number of protons multiplied by the charge of each or of one proton. Let's replace Q is equal to, we have 5,000 electrons, so it will be 5,000 multiplied by negative 1.6 times 10 to the power of negative 19 plus, for protons we have 4,800. So 4,800 multiplied by 1.6 times 10 to the power of negative 19. Doing the calculation, we will get negative 3.2 times 10 to the power of negative 17 coulombs. We got a total negative charge since the number of electrons exceeds the number of protons. So another example, consider a neutrally charged object. So initially, the initial condition, the object was neutral. Calculate its charge after it loses 200 electrons. So the loss of electrons resulted in a charge, we will call it Q. So since the object was initially charged and now it carries a charge, then this charge is directly related to the loss of the 200 electrons. So Q is equal to the number of electrons multiplied by 1.6 times 10 to the power of negative 19 coulombs. So Q is equal to 3.2 times 10 to the power of negative 17 coulombs. Now the question, why did I use 1.6 10 to the power of negative 19 and not negative 1.6 times 10 to the power of negative 19? Okay, when it lost 200 electrons, it means that it became positively charged. It means that it lost electrons, so the number of protons in this case is greater than the number of electrons. So it lost 200 electrons, then the number of protons is 200 more than the number of electrons. Later on we will see how we solve such type of questions in a different way. Consider a neutrally charged object. Calculate its charge after it gains. This time it gains 200 electrons. Again, the initial condition, Q initial is 0 coulombs. It was neutral or neutrally charged. And after it lost, after it gains, so there's a gain of 200 electrons. After it gains 200 electrons, we will get a certain charge. Okay, gaining 200 electrons. Initially it was neutral and then it gains 200 electrons. It indicates that the number of electrons is greater than the number of protons. Or I can say, when it was neutral, the number of electrons and the number of protons were equal. So now, after gaining 200 electrons, then the number of electrons is equal to the number of protons plus 200. So Q in this case is equal to N multiplied by E minus, because it gains electrons, so it became negatively charged. So Q is equal to 200 into negative 1.6 times 10 to the power of negative 19. So Q is equal to negative 3.2 times 10 to the power of negative 19 coulombs. Okay, I will solve it in a different way. Okay. Let's say we will apply the charge of an object is equal to the charge of electrons in this object plus the charge of protons on this object. I will use this relation now. Okay, so Q is equal to the number of electrons multiplied by the charge of each electron plus the number of protons multiplied by the charge of each or of one proton. So Q is equal, instead of the number of electrons, I will write number of protons plus 200 all multiplied by E minus plus number of protons, leave it like that, multiplied by P plus the charge of one proton. So Q is equal to NP into E minus, let's distribute, plus 200 E minus plus NP P plus. So what I did is that I distributed the E minus into the brackets. Now we will get Q is equal to, let's take a look at what we have. You will see that we have this part NP into E minus and NP into P plus. They will cross out because this will be the number of protons multiplied by negative 1.6 10 to the power of negative 19. This is the number of protons times positive 1.6 10 to the power of negative 19, so they cross out. So the only part left is 200 into E minus, which is negative 1.6 10 to the power of negative 19, and we will get the final answer for Q as negative 3.2 times 10 to the power of negative 19 coulombs.